It just works? Okay, great. Hi, everyone. I'm Kendra Brown. I'm the data manager of the NCCR Microbiomes, and I'm very happy to be here today to introduce our pitching competition for the SMF. So we have 4 early-stage entrepreneurs who are also active researchers whose projects represent a wide array of microbiome applications. So I don't have a... Thank you. Okay. All right, so each of them will give a 3-minute pitch of their project, followed by 3 minutes of questions from our jury members. And we're counting on all of you to participate by voting for your favorite pitch at the end of the session. And the most popular pitch will receive an audience prize of 500 francs. And then our jury members will also award a prize of 1,000 francs. And just to be clear from the outset, the same person could potentially win both of these prizes. So that brings me to introduce our jury. So you've already met Professor Emma Slack. You may not know that she leads the mucosal immunology lab at ETH Zurich and the University of Oxford. And a part of her work is to develop precision microbiota engineering to enable its adoption in human and veterinary clinics. And then Dr. Tim Mack, he is a principal scientist at DSM Firmenich, where he leads innovation projects in pharma, nutrition, and personalized health business. He also is a co-founder of Trilliome, which is a biotechnology research company that links clients and investors to innovative technologies. All right, so let's get the show started. I would like to introduce you to Fabio Palmieri. Fabio is a postdoctoral researcher at the University of Neuchâtel and a visiting researcher at CHUV, and he'll be talking about his project, the Micro-Lung Shield.
Thank you very much for the introduction. So, ladies and gentlemen, we are currently witnessing the emergence of fungal superpathogens. I'm, of course, not talking about the one depicted in The Last of Us, but rather of real pathogens that affect our health, and one specific case for which we have an unmet clinical need. I'm talking about Aspergillus fumigatus, which is a ubiquitous fungus that we all breathe, and that was recently selected as a critical priority fungal pathogen by the WHO. It is the causative agent of aspergillosis, which is a debilitating syndrome causing mild allergies to severe invasive pulmonary infections that affects more than 14 million people worldwide. Moreover, there are huge levels of drug resistance in this pathogen, and so we need alternatives to fight against it. Starting from the lung microbiota of human subjects, we isolated a series of bacterial strains directly in confrontation with Aspergillus fumigatus. And so as shown in the picture here, and then we tested and demonstrated their ability to inhibit fungal growth, as shown in the graph, compared to the control fungus alone in red, and the fungus plus voriconazole, which is a widely used antifungal compound in the clinic, in green. And the final solution will be the creation of functional bacterial consortia. Now, where are we in the business environment? So we really rely mostly on the use of antifungal drugs, but this drives the emergence of resistances over time. At Micro-Lung Shield, what we propose as a complementary approach to counteract this emergence of resistance is the use of biocontrolled bacterial strains. On the one hand, on the other hand, as you all know, the microbiome is a really hot topic at the moment, and there are a lot of pharma companies that work in this field, but they're all focused in gut health, or mainly. And so what we proposed is to subcontract the GMP manufacturing of the product in order to expand their portfolio and to give them a novel focus in lung health. We are a great and interdisciplinary team, and we have a plan to raise funds from the preclinical validation to the final product in 2030. And with that, let's protect your lungs from fungal pathogens, and we are looking for funding and investors. Thank you.
Okay, so now we have time for questions from our jury members.
Great, thank you very much. So as a first question, the patients who suffer from severe aspergillosis disease are, of course, people undergoing severe immunosuppression because of transplantation. Are you worried at all that these inhaled bacteria might cause sepsis in those patients?
Sorry, can you repeat the question?
So the patients that would be the target for your treatment are often under immunosuppression.
Yes, exactly.
Right? How certain are you that the bacterial strains you've isolated can't cause sepsis in those patients?
So we will perform safety tests in order really to see how, so if they are really toxic or not, and yeah, really to ensure safety first, of course, yeah.
And maybe related to that, do you have an idea of what the mechanism is that those bacteria use to suppress the fungal growth? Are they secreting effectively an antifungal, or is it sort of nutrient competition?
So we don't really know at the moment, so we are also currently extracting the DNA in order to analyze the genome and also to do transcriptomics analysis with the fungus to see really how they act in order to suppress the growth. Yeah. Thank you.
Hi, Fabio. Thanks. 2 questions from my side. What's the patent status at the moment for this project or your startup?
What is, sorry?
Your patent status, your patenting.
Yeah. So we are currently beginning to file the patent. So in order to protect the strains, so the use of the strains, sorry. Yeah. So it's ongoing.
And when you talk about the bacteria consortium, like how many strains are those, and how do you have any comment on scaling up in the end?
Yeah. So so we have roughly a dozen strains approximately, and what's also really like easy to handle them because they're growing in oxic conditions. So yeah, compared to most of the anaerobic bacteria that you can find in the gut, they would be much more easier to produce and then to build the consortia.
Okay, thanks.
Thank you.
All right, thanks very much, Fabio. So our next presenter will be Tania Miguel Trabajo. She's a PhD student at the University of Lausanne, and she'll be talking to us today about Bactil.
Good evening, everyone. Today we're hearing about microbiomes and their potential to help us with our health, our environment, the soils, agriculture. And this is why I'm here today, because I think microbiology is fascinating, and I would like to share that fascination with the world. Today, I would like to present to you Bactil, an educational board game that teaches you microbiology. And it specifically focuses on children, because they are the future microbiologists. In Bactil, you play as a bacterial species that lives in the environment. And your goal is to survive by defending yourself from the harsh conditions and benefiting from the good ones, so you can multiply. We tested the game, the educational component, and I'm very proud to say that Bactil works. So after just playing 15 minutes of the game, people were already learning microbiology. And this didn't matter if the people, like you are playing with your children as a family, or if the kids were playing on their own. Now, our plan is very straightforward. First, we need to spin off Bactil. After that is done, then we can start manufacturing, either industrially or at home. But in any case, we plan to launch Bactil, the latest this Christmas, through a direct sales business plan. Now, in parallel, we would like to bring Bactil to other countries of Europe, since the game has already been translated to other languages. But all in all, we expect that after only the first year, we get the revenue of around 7,000 francs just in Switzerland. Now, what we can do with your help? Well, today's prize will all go into creating a company. Because as you may know, here in Switzerland, you need an initial capital in order to create one. Now, just to put it into perspective, this prize will allow us to produce already 70 copies of the game. But the most important thing for me, that does not depend on winning any prize today, is that I can reach out to you for talent. Because Bactel right now is mostly me, and I need advice. So I need guidance, I need business expertise, I need manufacturing strategies, legal advice, to bring Bactel to as many people as possible. So as I said, Bactel is mostly me, with the invaluable support of NCCR Microbiomes through Evan Dorsey, and the advice of Philippe Picardi, who illustrated the game. So if you are passionate about board games, you like microbiology, or both, please don't hesitate to reach out. And together, let's inspire the microbiologists of the future. Thank you.
All right, questions, feedback from the jury?
Thank you very much. So I see you tested this with kids and asked questions. Is one of the ideas to actually market this, not just generally, but also to schools, and what sort of age range you aiming at? And you know, could somebody like me even use this with students in higher education, you know, to teach microbial ecology and this type of,
Yes.
you know, how big is the range you can apply the educational aspect of
So, indeed, schools will be, of course, a great target, but when you build your business model, you need to focus on one specifically, and schools sometimes is maybe a bit challenged to introduce this kind of new things into the curriculum, so I decided to target overall children. I played the game from 4-year-olds to 62. Everybody learns, there's no correlation with age, really. The focus group, though, for me, was elementary school, so primary school, sorry, from 8 to 12. They really enjoy it. I haven't focused on other groups like, for example, young adults, but the data points that I have is that still they learn and they like it, so potentially I don't see there's a limitation regarding age.
Hi, Tanya. Thanks a lot. I'm a big fan of awareness. I think everyone should know about microbiome or bacteria in general, so great work. Just 2 questions from my side. The first one would be, when we talk about microbiome, people think about bacteria, and with your title too is Bactel, and you have so many microbiome, fungus, phages. Are they also included in your games?
So the first version, like Bactel as it is right now, focuses on bacteria specifically. Now, the idea, of course, is that microbiomes are not just bacteria. So this, I guess, is kind of a dream, but there will be other expansions of the game where you introduce fungus, and you introduce virus, and you introduce other aspects of microbiomes themselves. So yeah, but this first version is mainly bacteria, and we introduce also the idea of bacteriophages, but yeah, in that sense, is bacteria.
First version, second version, that kind of. Yeah, thanks. I have one more question regarding the translation part, because, for example, I don't even know what's microbiome in my mother tongue. And I just wonder, how do you do it, if I say in Spanish or something? Because in a way, scientific publications are always in English, and we are mostly comfortable talking about scientific terms in English.
Yeah, indeed. Well, in this case, I originally made it in English. It then was translated to French, because I studied in the University of Lausanne, and we tested it there first. Then it was translated to German, with the help of the colleagues, and I translated myself to Spanish. I didn't find the process myself hard at all, because in the end, the words are very similar, and the concepts are still there. So in any case, yeah, I don't know if that answers your question, but in terms of language, I don't see that that will be a limiting factor.
Okay, thank you.
Thank you very much, Tanya. Our next presenter will be Maud de Vries, who is a postdoctoral researcher at the University of Fribourg, talking about Biome Shield.
Hi, everybody. My name is Maud, and I'm a bioengineer and founder of a startup project that wants to develop natural plant protection products. Now, why do we do that? Can you think of a versatile, unassuming hero that shaped human history? It's a silent protagonist that brings comfort and joy and warmth. May I present to you the extraordinary potato? Now, if you look back in your history books, you will see that more than once, while humankind was out there conquering the world and occasionally making a huge mess of things with wars, this petite, fat-free, gluten-free, vitamin C-packed energy bomb was saving us from famines and from diseases. And it is today our most precious ally in our fight against famines and against food shortages and malnutrition. And yet, we do not at present have the means to produce it in a sustainable way. Now see, the problem of potato is that it has a #1 enemy called potato late blight. And this disease is so devastating, it can destroy an entire potato field in just 2 weeks' time. Currently, conventional and organic farmers heavily rely on the use of pesticides to protect their crops. But they spend over $1 billion actually every year in Europe alone on these products. But they are also very harmful to the environment and human health. So they are being restricted or taken off the market, making it even more difficult for potato farmers to produce their potatoes. We want to replace these pesticides with eco-friendly and safe alternatives. Now, me personally, I'm from Belgium, so I've been thinking about this for a while now. And I do believe that we may have found the solution in the potato microbiome. So like we have a gut microbiome or a vaginal microbiome that impacts our health, potatoes also have their very own microbiome that contains microorganisms that can ward off diseases. And we have successfully identified protective microorganisms from potatoes, and by carefully combining microorganisms with complementary modes of action and adding an adequate formulation, we want to develop natural plant protection products that farmers will be able to apply directly on their crops to protect them. And unlike currently used pesticides, our products will be safe, eco-friendly, have no restrictions of use, and there will be no risk of resistance building by the pathogen. And this technology is also transferable to other crops and diseases, such as onion, grapevine, and other vegetable and arable crops. So by harnessing the power of nature itself, we want to provide solutions for new nature-based agricultural practices that will ensure sufficient, safe, and sustainable food production on a global scale for the future. We are now currently looking for funding to develop our formulation, so if you have any ideas or tips, or if you feel like joining us in our endeavors, we would be very happy to hear from you. So let's save some potatoes together, and thank you for your attention.
Hi, thanks a lot. You talk about potatoes quite a lot. I eat more rice.
Same thing.
Does it?
It's complementary.
Does it? Okay, so which is the one works best for the product that you have at the moment? Is it potatoes? Is it something else? Or
Sorry?
which kind of plantation, like food-wise, which is the best works for your product?
Well, potato is the 4th most important crop in the world, but it also
I
depends.
agree about rice too, but anyway.
Exactly, exactly, but it's still the 4th, so.
So potatoes means, I mean, your market is more covering potatoes or other crops.
We are starting with potatoes, but then also members of our team are working on grapevine, and we want to extend that. And the reason we choose potato also is that there is so far no solution, no organic solution for potatoes against this disease. So this is really an urgent need, as also the government in Switzerland, but also in Europe and other countries want to ban pesticides and copper-based pesticides, but they can't because there is no solution.
Okay, I have one more question. I mean, your end user in the end are farmers, and do you have any kind of feedback from them, like what kind of fertilizer to use of your product, kind of acceptance-wise?
So we are in contact with some farmers, and they also give. We ask them, okay, how could the product be used? So we have feedback from them in this regard. And for now, we are doing field trials, but not yet with farmers themselves. But this is planned for the next few years, so that we can really adapt them to their needs and to the possibilities that they have.
I think next time try rice as well.
I will think about it.
Okay, so I have the predictable question, if you're allowed to speak about it, because I guess this could be IP relevant, but you mentioned that you're making assemblies of microbes with complementary functions. Are you allowed to tell us what those functions are?
We are looking at different modes of actions. So most of the bacteria do produce compounds that are active against the pathogen itself. So this is to avoid resistance building, but also some might facilitate the survival of the others, and so that we could have products that are stable under different weather conditions, and UV and rain, for example.
Okay. And then maybe related to this weather conditions and rain, sort of how often do you think the farmers would need to apply this? Because I guess in terms of the business case, it would even be not great for you if they can apply it once and then that field's good forever.
That would be the ideal.
You want it.
Yeah,
that's great for the farmers, but.
Yes, the thing is that we start from the fact that farmers now they have to treat about 10 times. So they're already treating a lot. So we want to reduce this number, but we would want to start also with 10 and see how much we can actually extend that period of time. Because that would be a huge advantage for the farmer as well.
Great, thank you.
Thank you.
All right, thank you, Maud. Next, we will be hearing from Estelle Clerc. She is a postdoctoral researcher at ETH Zurich, and we'll be talking about Cellex Biosolutions.
Hi, everybody. I'm Estelle from Cellex, and I have a question for you. Did you know that water pollution kills more than 9 million people per year? We have pesticides, oil, pharmaceuticals, and many more that affects our health, but also destroys our environment. The problem is that pollution treatment methods, they're not up to the task. On one side, industrial methods, they are very expensive, like burning, or really not sustainable. And on the other side, bio-based methods are emerging, but they remain early stage because we are not using the most performant organisms. But what if now we could bridge this gap? What if now we could bridge this gap and bring biological solutions to the next level? Well, this is the solution we're working on at Cellex by finding and scaling naturally potent bacterial degraders. We have developed a novel microfluidic technology that acts as a selective screen for bacteria that goes into a robotic enclosure that together we deploy in situ in remote environments, like in the deep ocean, and can attract and capture bacteria that can degrade our pollutants of interest. We then bring them back into the lab and we grow them in large volumes. Now we have candidate degraders for the infamous PFAS forever chemicals, but also pharmaceuticals, microplastics, and pesticides. So how does it work? Well, in industry, they produce and store large volumes of chemical byproducts into reservoirs and get rid of them periodically by disposing them through burning. So we want to bypass burning by providing a custom bacterial culture starter that will be directly implemented in these chemical reservoirs, degrade this waste down to concentrations that are then disposable through the normal wastewater stream. This will be way more cost efficient and sustainable. There's definitely a large potential for this, with a market of more than $26 billion yearly, and is expected to increase by 82% until 27. So last year, we have been working on building a bacterial degrader bank and have already obtained, among others, PFAS product, and we have also acquired our first client in pharma, a scale-up partner for our PFAS products, and obtain our first 20K. This year we're focusing on optimizing biodegradation and scaling up our cultures to be ready for our pilot with our industrial collaborators of the Wasserversorgung of Zurich, and then pave the next steps for industry-scale pilot implementation and commercialization next year. So you'll see we're the right team for this. I bring the science, Christian here in the crowd brings the engineering, and our team of advisors give us strong guidance to move forward. So let's step together towards a greener future. We aim to raise 600K by the end of the year, and you can help us today by voting for CELEX. Thank you.
Thank you very much for a lovely presentation. How expensive will it be to produce these bacteria at scale and operate? Would you do this? Do you envisage this would be in the context of standard wastewater treatment, or could you even envisage that this could be relevant in sort of humanitarian settings, like dealing with pharmaceutical waste from field hospitals?
So at first we're targeting companies that can afford to try out these new ways of biodegradation and sustainable waste disposal. So that's why we're targeting pharmaceutical companies and also the public sector. And it would be easier to, to isolate the system so that we can also have a more monitored environment. But in the future, I really want to be able, for example, to derive enzymes from these consortia of bacteria to be able to directly use them in situ, because it will be way more easy to do so like this.
Okay, so it'll be lower technology requiring in situ, basically. You could just take the enzymes and dump them into your system. And then just a follow-up question about the breakdown. So do you know what, sometimes if you break things down, you create a new problem. So what do you know about the pathways being used and what the end products are that are coming out of your degrading bacteria?
So this is something we're looking at now with mass spectrometry. So we are assessing biodegradation rates and efficiency through mass spectrometry measurements, and we're also looking at the byproducts, not to degrade something in something even more toxic, basically.
Yeah, hi, thanks a lot. Few questions from my side. The first one, probably you have it on the slide too, like your USP. Right? I'm quite curious about what's your USP compared to other competitors that you have.
So first of all, would be most important is cost efficiency. So we want to be the most competitive with our sustainability aspect. That comes, I think, quite importantly as number 2 in our USP. And then the third one would be scalability.
Who's your competitors? Or do you,
Sorry?
Who is your main competitors?
I didn't understand.
Your main competitors, who are?
Main competitors would be, there's different ones. So I would say first there are the traditional, methods, like we're not even looking at them as competitors, like burning. But otherwise, genetic engineering, obviously, and traditional biodegradation, although it's not up there yet to be at the industry scale for some of them. Otherwise, electrochemical degradation, but that wouldn't be considered biodegradation. But they all represent downsides as well that we could overtake.
I see. And when you talk about strategic partners, because you mentioned about pharmaceutical companies, how about others players, like what you mentioned, wastewater or chemical industry?
So we are entering a collaboration with the water supply of Zurich City to directly address their needs. I cannot disclose exactly what it is, but we also, our first client is a pharma company, so we will be developing something tailored to their needs directly. But this method is really opening us the doors to address any kind of problems. It can be also in the chemistry industry, and it has a lot of potential in that sense.
Okay, thank you.
Thank you.
Okay, so at this point, it is time to vote on your favorite pitch. Oops. Okay. Great. Okay, so take out your smartphone, scan the QR code. Okay, and you can still continue to vote if you haven't yet. We'll wait for this to kind of come to steady state. All right, I think I'm going to call it. Congratulations to Biome Shield. All right. And for the announcement of the jury prize, could all of our pitchers come to the stage, please?
So, my goodness, that was hard to judge. Thank you for 4 absolutely fantastic presentations. You clearly all deserve a prize at this point. We struggled, and also you saw we didn't have huge amounts of time for discussion and deliberation. We love the game. We definitely buy it. In the end, our final pick, because of the level of innovation involved, of the technology development for really isolating new strains, novel strains from unusual environments, we decided to give the jury prize to Cellex.
All right, thank you so much to all of our pitchers. Thank you very much to our jury. Please join me in another round of applause.